We are supposed to find the Cartesian equation of this plane Q, which contains L and it is perpendicular to the plane P. Well, the equation of L is given to me, sadly, in the Cartesian form, so let's always try to change it. Okay, for lines, I'm going to go for the parametric form. Okay, so I'm going to change it into the parametric form. I'm going to let this entire equation here be, let's say, lambda, which means that x minus 1 over 2, this is equal to lambda. So x is going to be equal to 1 plus 2 lambda. And if I were to let y plus 1 over minus 1 be equal to lambda, this tells me that y is going to be minus 1 minus lambda, and z minus 3 over 4, this is equal to lambda. So z is going to be equal to 3 plus 4 lambda. With this, I know the equation L. The equation of the line L in the parametric form is R is going to be equal to 1 minus 1, 3. In fact, it is the point A. So 1 minus 1, 3 plus lambda of 2 minus 1 and 4. So 2 minus 1 and 4. Okay, and this is a vector that is going to be parallel to L. And if this is a vector that is going to be parallel to L, it will also be a vector that is parallel to Q. I need one more vector that is also parallel to Q in order for me to take them, cross them, okay, which will produce for me the normal vector to Q. This other vector, I can obtain it from the normal vector of P. Because for the normal vector of P, it is 1, 2, minus 3. It is perpendicular to P, so it must be parallel to the plane Q. Okay, so with that is given, and this vector that I have, which is parallel to L and Q, I can find the normal vector to Q. The normal vector to plane Q can be obtained by taking this 2 minus 1, 4 cross this, which is 1, 2 and minus 3, and I'm going to be getting a minus 5, 10 and 5. I'm going to simplify this. If I were to factorize out 5, I'll have minus 1, 2 and 1, and this is going to be the vector that I'm going to take as the normal vector to the plane Q, which means that Q will look something that is like this. Okay? R dot the normal vector minus 1, 2, 1 is equal to, I'm going to take a point that is on Q. An obvious point that I can make use of is the point of point A, so I'm going to take its position vector. So 1 minus 1, 3 dot the normal vector, and this is going to get me a 0. That is why the Cartesian equation for Q is going to be equal to replacing R here by x, y, z. It will be x multiplied by this minus x, y multiplied by this plus 2y, z multiplied by this is z, and this is equal to 0.